Okay guys, so there you go. There's my motor, my antenna rotor motor. Okay guys, so here we go. Well, here is a control box for the rotor up on the roof. This is an AR35, but if it's a channel master or so many different antenna rotors, they all work basically identical. They use a 2-winding induction motor, and this technique has been around actually since the 1940s, believe it or not. This is like a really old way of doing it, but it's a proven way, and that's why it's still around. Now, what's really crazy is that this box has the same motor inside it as the one up in the rotor, and we'll get into that in a minute when I pull this thing apart. But this is why it's so heavy and also makes that strange noise when it's running. And that motor that's running in there is just doing that for that dial. And it's basically, the reason they're doing this is because the two motors are exactly the same. They're going to be synchronized to the AC waveform as, you know, as it's moving. So, okay, I'm going to pull the cover off and we're going to take a peek inside this box. Okay, the screws are out of the back, and there we go. Look at the big motor inside the thing. That is the exact same motor that's up inside the rotor motor. And like I said, there is a reason behind that. And this is based on very old technology. Let's have two AC motors that run off the same power supply. They will be synchronized as they move because it's AC waveform, 60 hertz. So, and there's a big transformer. That is a 24-volt AC transformer. So really there's just a dial in here, and you can see the motor there. Actually, can you see it actually moving? Oh yeah, I can see some gears in there. Yeah. So, what's really going on here, and I'm going to use a screwdriver because this is live, but there is a big capacitor in there, and see it says NP on it, is non-polarized. And I'm going to disconnect the power so we can start poking around in there. Stand by. Okay guys, so here we go. This is basically how these motors work. As you saw 4 windings. Well, 2 of them are in series, so 2 of them, that would be like this one up here. The other 2 would be in series to create this winding down here. Now, it does say start winding and main winding. Basically, they're both windings. The only difference is this capacitor, if one of them has a capacitor in the circuit or the other one does. And the way you switch that capacitor between the 2 windings is with a switch. And as we see here forward, that switch would be there. This winding here would be getting power straight, while this one would be getting power through the capacitor, which would cause a phase delay because the capacitor takes a time to charge and discharge on every AC cycle. This causes a phase shift in the AC cycle, causing this winding to be getting power, its phase or timing, slightly later on than this coil here. Now we reverse the switch and the opposite happens. This one gets power right away while this winding would get power through the capacitor. So you see what happens. Now the motor would turn the other way. And that's basically how these reversible induction motors work. Now why it says start winding and main winding, because motors, say in your furnace that are running the fan or the fan in your air conditioner or a compressor, work the same way, but they run in one direction, but they use a capacitor. A lot of times people think it's a start capacitor because you won't start without the capacitor, but the capacitor is actually there. It is a run capacitor. It is just there to create this phase delay. And, you know, those machines run in one direction only, but this is how single phase induction motors work. They all use a capacitor, and they are reversible by reversing where the capacitor is in the circuit between the 2 different windings. So there you go, guys. Okay, now that the power has been safely disconnected, we can look at this capacitor in here. It is a 50 volt, 170 microfarad capacitor. And okay, guys. So keep in mind, this motor, even though it looks like there's 4 windings there, 2 of them are in series. So there's actually, it is a 2-winding motor. And the capacitor is used between the 2 windings. We'll get into that. I'll pull up a schematic. By reversing the power on the capacitor, it will cause it to go in the other direction, reverse. And this is because the capacitor is actually used to create a phase delay. So there's actually 2 phases going in this motor. One is ahead of the other, and that by reversing those 2 phases, you can reverse the motor. And this is how it's done with AC motors, making AC motors. This is actually a single phase motor, but they're using the capacitor to create, it's powered off a single phase, but they're using the capacitor to create a delayed phase or a second phase. Okay. So in the next part of this video, we are going to replace this big, clunky, outdated technology from the 1940s with a modern remote control. And using this remote, I will be able to just press a button and make my antenna rotate one way or the other. I have a camera up on my antenna so I can see where it's pointed. So that's all I really want to do. And this will allow me to control the motor from pretty much anywhere I want. And the way I'm going to do it is with one of these remote control receivers. It's got two buttons that momentarily latch one relay or the other. And you can probably figure out where we're going from here. We're going to steal this capacitor out of here. And we're going to wire it across these 2 relays. And yeah, that's how we're going to... Now that big transformer, I'm not going to use that. It is just 24 volts AC. I'm going to steal 24 volts AC down in my basement off of my heating and air conditioning system. There is a transformer down there, which is only used to open and close dampers for zoning of the air conditioning system. And it only momentarily uses that transformer, though the transformer's on all the time. And yeah, good place just to tap power, because we're only going to be kind of momentarily using that power too with this remote control. Okay, so we are going to start trying to set this up, and it's going to be cool when it's done. Okay, so I've powered up the little receiver with 12 volts, and in order to program in these remotes, the way you want it is you just go here and you push that button, and then you push the button on the remote. And there, it's learned that one. And you can actually hear the relay clicking when I press this button. And I do the same for that one, and program, there it is. Okay. Okay, we're all set. That receiver is now programmed with that remote. And we can now wire it up, and that'll be the next step. Okay. Okay, next step will be removal of this capacitor. Yeah, I'm just going to use some utility scissors here and snip that off. And let's get the other one out of here. There we go. Okay. So there's our beautiful non-polarized 170 microfarad capacitor, 50 volts. What non-polarized means is that it does not have a positive and a negative. If you don't have a non-polarized capacitor, you can actually make one out of 2 polarized capacitors. It would you'd be basically putting the 2 positives of the 2 polarized capacitors together, and the only effect you're going to have is that it will add the capacitors too. It'll be non-polarized, so if you took 2 100s and put them together that way, you would end up with a 200 microfarad capacitor. Pretty close to what we got here, so it probably would work the same. I believe the higher the value, the faster the antenna will turn. That makes sense because it's going to charge and discharge at a let's see, a higher value would turn the antenna slower probably. Smaller value would turn it faster. So this is why it's very important when you're replacing capacitors, say on your air conditioner, to put the proper one in, because otherwise it's going to be running at the wrong speed internally, and that could actually damage a compressor if it's too far off. Okay, so we are now going to start wiring this up. Stand by. Okay, so with this little remote control, these two terminals here are the power input, 12 volts. This one here is the antenna. There's just a small piece of wire on there, probably extend that a bit. So this relay, which is button A on my remote right here, is those two screw terminals, and I got my test probes on it, and I will press the button and there we go. So we know that that one works, and of course I put my probes on those other two screws there, channel 2, should do the same thing, and that's all there is to it. So basically we're going to put the capacitor across from, okay, so that's one switch and that's the other switch. So we'll put our capacitor, basically we'll probably bridge those two, and we'll put the capacitor from there to there. And then those will be the two wires to the motor as well. And the center two screws will be tied together. Those will be our common power coming in. Okay. Okay, I'm really happy how this is coming along. What I'm using here is actually a terminal strip. It's kind of a great way for, you know, combining all your wiring, and also it's a very secure way of holding components like that capacitor. Quickly, I'll just do a little rundown here what's actually going on. Starting over here, these two terminals will be my 24 volt AC power input. This one here, of course, doesn't have anything on it yet. This would be the common wire on the rotor. The other power wire here is these two yellows, and it goes to both relays. And the output of the two relays are the two red wires, which come over to each side of the capacitor. And then from there, these other ones loop out. So this would be rotor phase wire 1 and phase wire 2 to the rotor. And that's basically it. And that's all we need to control with this remote. You can hear those relays clicking when I press these buttons. So we're going to wire this up now to the rotor, and then we're going to try it out, and it should be exciting. Oh yeah, that black wire, that is my antenna, and I've cut that to be resonant at a partial wavelength of 433 megahertz. Okay guys, stand by. Okay guys, so this is the 24 volt transformer I was talking about, which runs my HVAC. It runs just the zone dampers, which are these things. There's thermostats that control, you know, the temperature in different rooms, and those open and close. Anyway, that transformer has power on it all the time. It is a nice big transformer. As you can see, that's several amps. So I also found this black and white wire right here, which is not being used. That was part of an old air conditioning condenser outside that was upgraded, and so that's available. I'm going to tie that into 24 volts, and that runs conveniently right where we need it. There it is right there, that brown wire. So I'm going to cut that brown wire, and this right here, this blue wire, I just ran this, that's the rotor motor up on the roof, and I've run that down here. So we're going to place the control right up here somewhere, and yeah, the 12 volts will come from this box here. This is got 12 volts in it. This powers all kinds of things. It's a nice big computer grade Dell power supply. I kind of made this box myself, as you see. I cut it up, but it's really great. It's got all the fuses in there, because that's about 25 amps at 12 volts. And it's also got 5 volts outputs, so that's what those fuses are. They're around probably 2 amps each, and those power circuits power all this stuff over here. Instead of having a whole bunch of plug-in power supplies, I just have this big guy here, and he's got 10 circuits coming out of it, running all kinds of things. It's a really cool way of doing it. So there you go, guys. We are going to start wiring this up. When it's done, we'll go up on the roof with a little remote control and we'll make that antenna run. It's going to be really cool, guys. Stand by. Okay, guys, so I have tapped into the power with these 2 wires, and I also put a fuse on it, so it has its own fuse, and there's the white and black. And I use some crimp connectors, so it's a really good connection. And that is running over to, there it is there, all wired in. It's got power, and look at that, there's our big capacitor. We got the blue wires coming from the motor. The green is common, and you can see it's connected to the black from the power source, the brown wire, and the white is also power. So there's 2 yellow wires going, and 1 to each relay, and then from each relay out, the 2 red wires across the capacitor, and then those 2 red jumpers going to the orange and blue. Those are the 2 phase wires going up to the motor. So there you go. And on the side here, the black wire, that's the antenna, and I just stapled it vertical. It's the best way to do it. And there you go. Okay, guys, now I'm going to go up on the roof. We're going to try this out. Okay, so we're up on the roof. Look at this. Wow. I love that. And I'm doing that with this remote control right here. Love it. And who do you know has a camera built right into their antenna? Okay, guys, I'm inside now. And the view you're looking at here is the antenna cam. And I have the remote control right here. And here we go. Look at that. Isn't that cool? This is how I point my antenna. I just see where it's pointing. Really great. I'm going to go back the other way. So there you go, guys. That's how these motors work. And you might find these motors at garage sales, old ones that people had on their house, but they don't know where the control box is. And if you follow my instructions and you just get a capacitor, 50 volt, non-polarized, or you make one out of 2 polarized capacitors, somewhere in the range of 170 to 200 microfarad, and a 24 volt transformer, just like what I'm using, you know, one that powers an HVAC system, the remote controls on it. You can easily get these motors working again and use them for rotating your antenna, which I'm doing here. So I hope you enjoyed that little video. It's actually a lot of pieces to it. And yeah, so you know what to do. Subscribe, give me some thumbs up. I appreciate it. And I am going to be doing a lot more coming very soon. Okay, guys. Thank you very much. Have a good one.